So we just took a look at when do we use each of our laws, and we looked very briefly at what cosine law is. Now we're going to be taking a look at a couple of examples of how do we use cosine law. The first example that I'm going to give you is all about how do we use it to find another side. So if we have two sides and an angle that's surrounding those, or that's in between those two sides, can we find the third side? The second example is going to go through how do we solve for an angle using three sides, and that's going to involve some manipulation. In that case there, I'm going to manipulate and show you a different formula or a different version of the formula, and you might want to make sure that you copy that one down. But let's start off with looking at when we have a side, and the angle that is surrounding those two sides. All right, first thing I'm going to do here is I'm going to label our triangle here. So we have our angles, A, B, and C, or vertices, and so I'm going to label the sides that are related to those three vertices. So remember that A is across from A, C and C are across from each other, and little b is across from big B. Now, I'm going to just show you what this would look like in sine law. So if we pull up sine law here, and I'm going to quickly write out our sine law. Sine of A over little a is equal to sine of B over little b, which is equal to sine of C over little c. There we go. And if we put in the information that we know, okay, we know A, 58 degrees, over little a is equal to sine B over little b, which is 32 meters, over 32 meters, there we go, which is equal to sine C over 40 meters. Okay. So if we put this in here, we'll notice that all of our ratios are missing one piece. Okay. So in the first one here, we're missing little a. The second one, we're missing big B. And the third one, we're missing big C. In the case of this triangle here, we actually cannot solve for any of the other angles right now. We don't know what these two angles are. This is not an isosceles triangle by the fact that these two are different lengths, okay? Or at least these two are different lengths. We don't know, unless maybe this one's 40, but we don't know that. Okay? We're not told it's an isosceles triangle. So that means that we're going to have to use something else, okay, to solve for little a, okay? Because that's what we're trying to find. We cannot use sine law because it does not have the right stuff. It doesn't have proper pieces. So we can't use sine law or the law of sines. We can't because it does not have a full ratio. So we don't have this full ratio, we don't have the second full ratio, we don't have the third full ratio, so we cannot use the law of sines or sine law. That means that we're going to have to use cosine law. Now I'm going to write out cosine law, and I'm going to put it in the form that we're actually going to want to use it here. So we have a squared is equal to b squared plus c squared minus 2bc, and then we multiply times cos of a. This is sine or cosine law right here. I've given you all of them up on top here. Okay, we're using the first one. Right here, there's a dot for multiply. I am going to use the multiplying sign. The program I'm using right now doesn't really have the dot. So I'm going to use that multiplying sign. So this is cosine law. Now I want to just show you a couple things about cosine law. Number one, it deals with all three sides. Okay, so it deals with all three sides, and you'll notice we have A, B, and C right here. And then two of the sides are repeated. The two sides which are repeated are the two that are right here. So B and C are in here. So those two are repeated behind the two. They're being multiplied to the two. Now, cosine law also has one angle. In this case, it's A. That angle is the same one as the angle or the side on the outside. Okay, so little a is here, big A is right here. You'll notice little a, big A, little b, big B, little c, big C. Okay, so when we relate it, okay, it's important that we understand that the side that is on the outside is the same as the angle that is on the far side. Then on the two letters on the inside, so B and C are being squared, BC is being multiplied. A and C are being squared, AC is being multiplied. B and A is being squared, B and A is being multiplied. The order of those two doesn't matter. We can do AB and AB here, does not really matter. That order does not matter. So this is cosine law. And we're going to be using this to solve for side A. You know, side A is on the outside here. So once we have our cosine law there, we can plug in the information that we know. We do not know what little a is at this point yet. Formula going, a squared is equal to, now B is 32 meters. And we're going to add C, which is 40 meters, and we're going to square it as well, minus 2 times 32. I'm not going to have enough room on this page here. I normally don't in my notes either, because, it might be enough here. And then we multiply by cos of 58 degrees. Woo, just fit. And I'll actually put the multiplying sign in here. There we go. Okay. All right. So we write this all down. Now this is a long kind of spiel or mess of things here, or a lot of numbers, but it's the way that we're going to solve for a. And in the case here, we're going to solve for a squared, and then we'll take the square root, just like Pythagorean theorem, and solve for a. Now, to solve for this, the simplest way is to use your calculator the way it's meant to be used, and to punch in everything in order. Okay, you could solve for this, and solve for this whole piece, okay, and then do the adding and subtracting. But your calculator knows how to do this without having to do all the squaring and adding separately. They can do it all together. So let's go through and use the calculator to solve for it. Remember, if you're going to use the Google calculator, or if you're going to have your own calculator, make sure that it is in degrees. Okay? Always start in degrees. All right, so let's put this all in here. And I keep on doing that. I keep hitting space bar, I should be doing that. Plus 40 squared minus 2 times 32 times 40 times cos of 58 degrees, close bracket. You'll notice here, I've punched this entire thing into the calculator. Okay? I did not skip anything. I did not miss anything. I just punched the whole thing into the calculator, because our calculators, as long as you have a scientific calculator, which most of you should, okay, it will already process all the adding and subtracting in the proper order. Once we hit enter, we get an answer of 1,267.40, and then a whole bunch more decimal places. Okay. So the answer, well, at least the current answer right here, is that a squared is equal to 1,267.40. Right, 1,267.40, and a whole bunch of dots, and this is in meters squared. Okay, don't worry too much about the units in this case here. We know that our final length is going to be in meters, and so if we've squared everything, it's going to be in meters squared. All right, so this is a squared. Now, we need to make sure that we are not just finding a squared, we need to find a. And remember when we went through Pythagorean theorem, when we solved for any of the sides, we had to take the square root of our final answer. So in this case here, we need to take, let's do blue, we need to take the square root of both sides to find our final answer. And so we're going to get that a, and I'm going to go back to my calculator here. I'm going to take the square root of the answer. Most of your calculators, you should just be able to hit square root and it'll give you the answer. And we get 35.600655662. And so our final answer is the length of the side is 35.6 meters. Or, and in this case here, it asks us to do it to the nearest meter. So A is equal to 36 meters. Okay, so that's going through and solving for that side length. Now, quick little thing that you'll notice here, 35.6 is right between 32 and 40. That means that 58 is our middle angle, okay? That means that C is going to be our biggest angle and B is going to be our smallest angle, and as A is our middle angle in that case there. And so we can then, and we know what our side length is. Okay, so important thing to remember, number one, okay, use the equation that has the side you're trying to find on the outside, okay, which will also have the side that or the angle you're given inside, and the two other sides that you're given. So using cosine law, we need to make sure that we're able to punch everything in. Okay, and remember, don't do it in separate steps. Okay, every time someone does, or most of the time when people do it in separate steps, they make mistakes. Often it's because they're adding cos of 58, and that's definitely wrong. So make sure that we do it all together, take the square root of our final answer, and then we can solve for what our side that's missing is.